Let's do a couple of u-tries. Find the arc cosine of root 2 over 2. The correct answer is pi over 4, positive pi over 4. Again, you can think of it as cosine. When you see arc, it's like what angle gives you a cosine ratio that's root 2 over 2. But the answer needs to be between 0 and pi. Well, cosine is positive in quadrant 1 only here, and that is at pi over 4, right? You get x coordinate, circ x, right? X coordinate equaling root 2 over 2 at pi over 4. What is the inverse cosine of negative 1? The correct answer is at pi. Again, you look from 0 to pi for inverse cosines. And where does your x value equal negative 1? That happens at pi. Find the arctangent of 0. The correct answer is at 0. So again, it's asking you, when is your tangent ratio 0? Where your angle is between negative pi over 2 and pi over 2. And so right here at 0 radians, that's 1 comma 0, and circ x, y over x gives you 0. So try this calculator problem. Be in radian mode. I'll tell you that in the directions. What is arctangent of negative 8.45? So in your calculator, you would put inverse tangent, right, second tangent of negative 8.45. Notice that here the ratio, because it's inverse, you have an input of the ratio, is greater than negative, it's outside of negative 1 and 1, but that's okay because remember it's only sine and cosines where the ratio is going to be between negative 1 and 1. If you remember the tangent graph, right, the ratio goes between infinity and infinity. Good news is this is a calculator problem anyway, so you can just type it in and give the answer. Right? In this case, it's about negative 1.453 rounded to the nearest 3 decimal places. Just a reminder of what you've just done. You are saying that the tangent of negative 1.453 radians is equal to negative 8.45. So you can go backwards and check it, right? Find the arc cosine of 2. The answer is undefined. If you plug this into your calculator, you will get an error message, or like domain error message, because remember for cosine and sine, the ratio needs to be between negative 1 and 1. Again, calculator, so if you get an error, you know it's going to be undefined. Now we're going to evaluate compositions of functions. Remember, compositions of functions or composite functions are like a function of a function. F of g of x, g of f of x, if you remember that type of a thing. So we're going to see things like sine of cosine of something or sine of inverse sine of something. Okay, here's an example. Find the exact value of arcsine of sine of 5 pi over 3. So I have arcsine and sine, so you might think that you can cancel these out, getting 5 pi over 3. But in this particular case, you cannot just cancel them out because recall that arcsine has a restriction between negative pi over 2 and pi over 2. So for this particular case, you cannot do that. Here's how you can approach it instead. Let's do the inside first. So we are going to find the sine of 5 pi over 3. Well, what is sine of 5 pi over 3? It is negative root 3 over 2. So then you do arcsine of negative root 3 over 2. So what is arcsine of negative root 3 over 2? That's going to be here at negative pi over 3. It's really just 5 pi over 3, but you're rewriting in terms of the coterminal angle in the negative direction so that your angle is between the restriction of negative pi over 2 and pi over 2. So final answer is negative pi over 3. So note that sometimes you are able to just cancel out the arcsine and sine because they're inverses of each other. So let's see when you're able to do that and when you have to take a moment and pause and think about how you can rewrite your answer. Let's say you have sine of theta and you notice that there's an inverse sine of that sine of theta. These can cancel out to get theta as long as theta, right, because inverse sine is going to give you a theta, is between negative pi over 2 and pi over 2. If you have inverse cosine of theta, so that inverse is on the outside, again, these cancel out, giving you theta, as long as your theta is between the inverse restriction of 0 and pi radians. And if you have tangent of theta in the inside, right, if you have arc tangent or inverse tangent of tangent, right? Because it's a function inside a function, or a function of a function. Again, these would cancel out if it meets your arctangent restriction, such that your theta is between negative pi over 2 and pi over 2. So if your arc sine or inverse sine or your inverse trig is on the outside and your angle meets the restrictions appropriately, then you can just undo these and that's going to be your answer. If the angle does not meet the restrictions, then you have to think about what answer would indeed make a restriction and convert it accordingly. How about if you have the inverse trig function on the inside? So let's say if you have an inverse sine and then you're taking the sine of that on the outside. Recall that when you have an inverse sine, the input is a ratio, right? So if you have like a normal sine without the inverse, your input is an angle measure and you get out a ratio. The inverse, right, is when you switch the input on output, you plug in a ratio and you get out a angle theta. So when you're given a ratio on the inside, you can cancel these out and say that whatever the ratio that was given to you is your answer, as long as it meets their restriction, right? Remember, your ratio for a sine graph needs to be between -1 and 1. And the same is true for inverse cosine. So cosine of inverse cosine, you can just cancel these out because they undo each other, and your answer would just be that same ratio, as long as your ratio is a number between -1 and 1. Otherwise, it would be undefined. How about for tangent? If you had inverse tangent and you see that it's the tangent of that, this is always going to be the ratio, because recall that for tangent, the ratio is all real numbers. It's between -infinity and infinity. So for inverse tangent, if you're given a ratio, right, the answer is just going to be a ratio. What is the tangent of arctangent of -5? Note that on the inside is the arctangent or inverse tangent, therefore what's given to you is a ratio. And for tangent, all real numbers is the possibility for the ratio, so these would just cancel out, and -5 is your final answer. Find the exact value of cosine of inverse cosine of pi. This one's a little sneaky one, because notice that you're given inverse cosine here, therefore what's given to you is a ratio. Even though it looks like an angle, it's actually a ratio. Again, cosine theta is equal to the ratio, right? But inverse cosine, you're given the ratio and you're trying to figure out what the angle is. So this is a ratio, and that ratio is about 3.14. Remember, for cosine and sine, your ratio needs to be between -1 and 1, and that is not the case for 3.14. So this is undefined. Find the inverse sine of 7 pi over 4. Note that on the inside, it's just the regular trig function, sine of 7 pi over 4, so what we're given is angle theta. And because that angle theta for sine is not between -pi over 2 and pi over 2, I can't just cancel these out and say that 7 pi over 4 is my answer. The shortcut way to do this is to find the coterminal angle of 7 pi over 4 that fits this restriction. So 7 pi over 4 is here, and if we were just to go in the negative direction, that would give me -pi over 4. So my final answer would be -pi over 4. Another way you could have done this is to first find sine of 7 pi over 4. So if you do 7 pi over 4, you'll see that it's -√2 over 2. And so you're finding inverse sine of -√2 over 2. And because you have an inverse, you need to look between quadrant 1 and quadrant 4 in the negative direction, and you would get the quadrant 4 answer going in the negative rotation, so it would be -pi over 4. Last type of problem, find the exact value. Find the tangent of arc cosine of 2/3. So notice this problem is different from the ones that we were just doing, because these are not just straight inverses of each other, like tangent, arctangent, inverse cosine, cosine type of a thing. These two functions are different. So when you have two functions that are different, it's a composite function because you have a function of a function. You want to draw triangles. Let's think about this. We see that arc cosine is of 2/3. That means cosine of theta is equal to 2/3, right? Because you're given the ratio when you have the arc or the inverse. So where would cosine theta equal 2/3? Well, we know that for arc or inverse cosine, our answer needs to be in quadrant 1 or 2. And since cosine is positive only in quadrant 1, that is where I'm going to draw my triangle. So adjacent over hypotenuse. Using the Pythagorean theorem, I see that the opposite side is root 5. In this case, it's positive root 5 because it's in quadrant 1. It's going the positive y direction. Therefore, my tangent of that same theta, because this whole thing is equal to theta, right? The tangent of this is now opposite over adjacent root 5 over 2. You can recall that it's positive because it's going the positive y direction, or just think all students take calculus. Tangent is positive in quadrant 1. Go ahead and try this problem. What is the cosecant of arctangent of negative 12 over 5? Okay, again, I notice that the functions are different, so I'm going to have to draw a triangle. I have arctangent that has a negative ratio, and arctangent or inverse tangent is in quadrant 1 and 4 only, and tangent is negative in quadrant 4, so I'm going to draw my triangle here. It's opposite over adjacent, so here's what I have. All right, opposite is negative y direction, adjacent is positive x direction. Using the Pythagorean triple or using Pythagorean theorem, you find that the hypotenuse is 13. So now you're asking yourself, what is cosecant of the same angle theta? Well, what is cosecant? Remember, cosecant has to do with sine, which is opposite over hypotenuse. In this case, we're going to have hypotenuse over opposite. So hypotenuse over opposite gives me 13 over negative 12. And that is your final answer.